Dear student, today we will discuss about the chapter 2 and the laws of falling body. Laws of falling body. Or we can say that is the equation of falling body. So, laws of falling body, laws of falling body. Three laws are described for the falling body. First law is the traveling distance of a free falling body in equal time will be equal. Suppose T1 equals to T2 and H1 equals to H2. This is the first law for falling body. Second, if a body is falling freely, then the velocity is proportional to time. Velocity of proportional to time. From this we can write B1 by T1 equals to B2 by T2. Suppose this is the ground and an object is falling in this direction. At first the velocity is 0. For free falling body, we know the initial velocity is 0, and it coming towards the ground or centered earth, then the center to the earth, then the velocity of the object will be increased. And this phenomenon is known as the second law of falling body, and it is known B proportional to T. From this we can say if time is increased, then the velocity will be increased. Okay, B proportional to T, and we can say from this B1 by T1 equals to B2 by T2. Third one, suppose their distance is h and time required to t. So it can say h proportional to t square. H proportional to t square. H proportional to t square. From this we can write h1 by t1 square equals to h2 by t2 square. h1 by t1 square equals to h2 by t2 square. Okay, this is the three laws. Now there are three equations for the falling body. Generally it is like as the equation of motion. Suppose we know first law, first equation B equals to U plus AT, and number two S equals to UT plus half of AT square, and number three V square equals to U square plus 2AS. For falling body, the equation will be V equals to U plus GT. U plus GT for falling body, and H equals to UT plus half of GT square, and V square equals to U square plus 2GH. V square equals to U square plus 2GH. This is the for falling body. If the body is throwing in upward direction, the equation will be V equals to U minus GT, H equals to UT minus half of GT square, and V square equals to U square minus 2GH. V square equals to U square minus 2GH. And this is the equation. Now we discuss about some numerical problems. Okay, come on. So we know from our discussion, we know here B1 by T1 equals to B2 by T2, and H1 by T1 square equals to H2 by T2 square. V equals to U plus minus gt. Plus for falling body and minus is for throwing body, and h equals to ut plus minus half gt square, v square equals to u square plus minus 2gh. Okay, and you can remember this for free falling body, free falling body, u equals to 0. Okay, come on. Question number 1. If free falling body travels 25-meter distance in 5 seconds, what will be the traveling distance in 15 seconds? What will be the traveling distance in 50 seconds? Okay. Let's try. Here, the traveling distance 15 meter, time 5 seconds, and the second time is 15 seconds. So we can write h1 equals to 25 meter, t1 equals to 5 seconds, and t2 equals to 15 seconds, and h2 equals to what? From this, we know this value supports the second one. h1 by t1 square, h1 by t1 square equals to h2 by t2 square. So h2 equals to h1 t2 square by t1 square. So h1 means the 25, t2 means the 15th whole square, and it will be the t1 equals to 25 square. So it will be 225 meters. So h2 equals to 225 meter. This is the traveling distance in 15 seconds. Understand? Okay. Question number 7. Suppose this is the ground and here is the object, and the mass of the object is 5 kilogram, and it's allowed to fall freely from the height 80 meter. From the height 80 meter. So first question is, what time is needed? What time is needed to reach the ground? And number B, what will be the velocity? What will be the velocity just before touching the ground? Touching the ground. What time is needed to reach the ground? First one. Second one is, what will be the velocity just before touching the ground? Okay, come on. What time is needed to reach the ground? For this, we know u equals to 0 and h equals to 80 meter and g equals to 9.8 meter per second square. And time equals to what? From this, we can write h equals to ut plus half of gt square, and it will 80 0 into t plus half of into 9.8 into t square. This is because this is the falling body. For falling body, h equals to ut plus half of gt square. So 80 into 4.9 t square. So t will be 80 by 4.9 the root over. Okay, understand? Okay. 80 by 4.9, 4.04. 4.04. So time required to reach the ground is 2.4 seconds. Okay, this is the one type. You can solve this math in shortly. I discuss about this after. So this is the question number 1 answer. And what will be the velocity just before the touching? You can solve this math in 2 ways. One is the equation is v square equals to u square plus 2gh, or b equals to u plus gt. Because now you can know the value of gt at what time it touches the ground. Okay, come on. The result, what will be the result? Okay, and b square equals to u square plus 2 into 9.8 into 80. So v equals to root over 2 into 9.8 into 80. So it will be 9.8 into 2 into 80. So it will be 1568. 1568. Oh, sorry, root over s. Okay. 39.59. 39.59, that means 39.6. 39.6. So B will be 39.6 meter per second. Okay. Next, B equals to U plus GT, U plus G 9.8 into 4.04. So, okay, come on. 9.8 into 4.04, and it will be 39.6. 39.6. Both are correct. You can do this in any way. This is the velocity just before touching the ground. Okay, come on. Now we discuss about some equation which we can use for to solve any MCQ type question. Okay. Now, suppose this is the object, and an object is throwing vertically upward with velocity u. With velocity u. What will be the maximum height? What time is needed to reach the maximum height? And what time is needed to reach the mean position? That means initial position. Okay, come on. Now, suppose in maximum, if you throw an object, it's going upward direction, and up to the velocity is 0. If any object is throwing upward direction, the velocity is decreased. The velocity is decreased. And when the velocity is 0, then the object is just falling. So you have to remember this at maximum height. At maximum height, the final velocity of a throwing object is 0. At maximum height, the final velocity of a throwing body is Throwing object is 0. Okay, now we can write, suppose maximum height. At first we determine the maximum height. Okay, maximum height. Okay, so maximum height, we know v square equals to u square minus 2gh, because it is the throwing body. Okay, now so at maximum height, max height, v equals to 0 and h equals to capital H. So 0 square equals to u square minus 2g capital H. 2g capital H equals to u square. So h equals to u square by 2g. This is the maximum height. H equals to u square by 2g. Understand? So we know the maximum height h equals to u square by 2g. Okay, you can use this formula to determine the maximum height. This is the maximum height. Then we determine how much time is needed to reach the maximum height. Time required to reach the maximum height. Okay, time required to reach the time required to reach maximum height. Okay, time required to maximum height. For this we know b equals to u minus gt. For max height by maximum height we can write v equals to 0 and t equals to t1. So 0 equals to u minus gt1. So gt1 equals to u. So t1 equals to u by g. This is the time required to reach the maximum height. Okay. Okay. So the another question, what time is needed to reach the mean position or initial position? That means from where you throw the object, it returns here. Suppose, come on, what is the required? So this is the ground. If you throw an object in this direction, it goes to upward direction, and after that is falling this and come to the initial position. And this time is called the time period. This is the capital T. This is the required time to reaching the upper final maximum height and return the initial position. So time period, we can write time period. Okay, time period. Here you have to remember this time period. For this time period, h equals to ut. You have to remember this. It is not considered considering the final situation. You have to consider the initial position. Initially, the object is throwing vertically upward. So for vertically upward, h equals to ut minus half of gt square. H equals to ut, as you can say, sir, after that reaching the maximum height, the object is falling. So why we cannot use the equation h equals to ut plus half of gt square? You have to remember this. The initial situation of the object is considered. Initially the object is throwing upward or vertical direction. So the object will be, the equation will be h equals to ut minus half of gt square. Understand?
Yes, sir.
Okay. So h equals to ut minus half of gt square. If an object is throwing in vertically upward and it reaches this position, and here h is the displacement, vertical displacement. So this is the initial position and this is the final position. So displacement, we know displacement equals to final position minus initial position, her final position and initial position are same, so the displacement is here 0. Here this height is the displacement, so you have to remember this. For this case we know this is the 0, h equals to 0. So ut minus half of g capital T square. Suppose that required time or time period is capital T, so u0 equals to ut, so it's also capital T, ut minus half of gt square, ut minus half of gt square. Okay, now come on, half gt square equals to ut, so you can write half of gt equals to u, so gt equals to 2u, so t equals to 2u by g, 2u by g, t equals to 2u by g. You have to remember this. Okay, t equals to 2u by g. This is the time period. Okay.
স্যার আমরা কি স্যার এইটা কি ডাইরেক্ট ইউজ করতে পারবো?
Yes, you can use this equation. Okay. We know to reach the maximum height t equals to u by g and time period equals to 2u by g. Okay. Suppose this was the ground and an object is thrown in upward direction with velocity v, and the time required to reach this position is t1, suppose, and after this time is t2. So we can write t equals to t1 plus t2. Okay, so t2 will be t minus t1, so 2u by g minus u by g, so u by g. So from this discussion we can say for a throwing body to reaching the maximum height and return to the ground from the maximum height, the time is equal, so t1 equals to t2. Okay, okay, there is a question, so you have to remember this. Question: an object of mass 10 kilogram is thrown vertically upward, is thrown vertically upward with velocity 25 meter per second. Okay. First question: what will be the maximum height? What time is required to reach the maximum height? C number: what will be the required time to return its mean position? Okay, let's try. আজওয়াদ, আব্দুল্লাহ, অলক, আবিদ, মুহাইমিন ক্লাস করে না?
না স্যার।
Okay. Okay. Count. What will be the maximum height? First question is what will be the maximum height? Maximum height, we know the equation of maximum height, h equals to u square by 2g, where u equals to 10 kilogram and suppose g equals to 10 meter per second square. Okay, consider it. G equals to 10 meter per second square. So mass m equals to 10 kilogram. Sorry. M equals to 10 kilogram and u equals to 25 meter per second. First question is h equals to what? Consider h equals to 10 meter per second square. Okay. So h equals to u square by 2g. H equals to u square by 2g. U equals to 25 square by 2 into 10. You have to know 25, 2 into 10. So 5 to the 2, 5. So it will be 125 by 4 meter. This is the maximum height. 125 by 4. This is the maximum height. Okay. Now, second question was, what time is needed to reach the maximum height? What time is required to reach the maximum height? For this, we know for the maximum height, this is the what time t1 equals to what? It was t1 equals to u by g, and u equals to 25, g equals to 10, so it will be 2.5 second. It will be 2.5 second. Okay. And time. What time is needed to reach is mean position? So it from this 2 equals to 2u by g at 2 into 25 by 10. So it will be 5. So t equals to 5 seconds. T equals to 5 seconds. Okay. T equals to 5 seconds. On the other hand, you can say, sir, t equals to 2t1. So 2 into 2.5, that means 5 seconds. You can use any types of the equation. So for this, okay. Now, last question we discuss here. And next class, we discuss about force and that chapter number 3. Okay, come on. Now, last question for this chapter and these topics for laws of falling bodies and equation of falling bodies. So last question is, this is the ground and the height of the, suppose this is the 180 meter, and object of 5 kilogram, an object is falling freely from the top position of the tower or any other type of building, and here an object is thrown vertically upward. Vertically upward. Vertically upward with কতটুকু? Vertically upward. Okay. Vertically upward with 40 meter per second. 40 meter per second. The first question is, what will be the traveling distance in 2 seconds for throwing body. For throwing body. Number B. When and where they will meet each other. They will meet each other. When and where they will meet each other. These and these are this object is allowed to fall, and this object is throwing at a time, at the same time in opposite direction. First one is easy. For A, first one, what will be the traveling distance in 2 seconds? For throwing body. For throwing body, H equals to, we know, ut minus half of gt square. So here, suppose here g equals to 10. Consider g equals to 10 meter per second square. Okay, now ut 40 into 2 minus half of 10 into 2 square. So it will be 80 minus 4 to the 10, 60 meter. So H will be 60 meter. This is the answer. This is the traveling distance in 2 seconds for the throwing body. Now, the second one is important. Second one, okay? Come on. When and where they will meet each other. Suppose from the ground x meter height, and after time t, they will meet each other. That means it comes towards this position and it goes this position. So at first for falling body, this is x and this also 180 minus x. For falling body, h1 equals to ut plus half of gt square. So it will be 80 minus x, 0 plus half of gt square. So 180 minus x equals to half gt square. This is the equation number 1. Okay. For throwing body, suppose this is the h2. h2 equals to ut minus half of gt square. So h2 equals to x, u means 40t minus half of gt square. Equation number 2. Now add the equation 1 and 2. So 180 minus x plus x equals to half gt square plus 40t minus half of gt square. This is the step. So and 180 equals to 40t. Okay, so t will be equals to 180 by 40. So here t equals to 4.25 seconds. Okay, 18 by 4, it will be 4.5, sorry. It will be 4.5 seconds. So after 4.5 seconds, they will meet each other. First question, when it is answered. So next one, where they will meet each other. If you putting the value of t in equation number 2, then you can know the value of x. Okay, now from second, x equals to 40 into 4.5 minus half into 10 into 4.5 the whole square. So it is 180 minus 4.5 square into 5, 101.25. So it will be 78.75. So x equals to 78.75 meter. At meter height, they will meet each other from the ground. If you want to know the value of the highest peak, then it will be from highest peak it will be 180 minus 78.75. So it will be 101.25 meter. So you can say after 4.5 seconds from the ground 78.7 meter height or 1012 meter below from the top point, they will meet each other. Okay, and this is the answer finished, and you have to practice any types of mathematical problem for this chapter, and any problem is arise, you can ask me the question in next class. Okay, thank you. Allah Hafiz.